Okay, today we are going to go through the Prelim 1 set for Express Pure Physics paper in 2015. So let's begin. You guys requested on question 9, 11 to 14, 16, 19 to 20, 33, and question 9E, which is in paper 2. So let's begin. Hopefully I can get this upload before breakfast. And I have disabled the webcam because I just woke up and I'm in a mess. So let's go to question 9. Question 9 is your typical VT graph. So in a VT graph, you should know that the area under it represents the distance and the gradient represents the acceleration. So down here you are being asked what is the resultant force, which part of the graph represent that resultant force on the car is 0. So right here you should know that your resultant force, which is your F net, is equals to ma, and hence if your F net is 0, that means your acceleration is 0, and that also means that on your VT graph, your gradient will be 0. So if you know this bunch of content, then you should know that you should look for a part whereby the line is flat, which is your R and S. So hence, your answer would be C. Okay, this one is not that challenging. Okay, let's go to question 11. Question 11 is a bit challenging, and the reason why is because it involves two body, one 3 kg block and another 2 kg weight, and there's a rope pulling it over. So why is this challenging is because now you have two bodies and you are told that the weight was released from rest and that it falls vertically downward, and you are given that there is tension. So let's analyze this, but I would definitely need to draw the free body diagram for this. So I'm going to copy this and I'm going to bring it here, and I'm going to use this. Okay, let's begin. Let's make this big. Okay, to do this, you need to draw two separate free body diagram. So one for the 3 kg, one for the 2 kg. So let's draw the 2 kg first. So this is my, oh, I don't like this. This is my 2 kg weight. So the 2 kg weight, definitely there will be a weight component here, which is equals to 2 times 10. That gives you 20 Newton. And on the weight, there will be also this tension down here, and the tension is given by the question. It is 15 Newton, as you can see right here. So therefore, this is the free body diagram of the weight. Now, it is pretty simple, and from here we can actually work out what is the acceleration of this weight already. So first, I will do the standard thing. I will just write down two equations, that the F net is the sum of forces and the F net is equals to ma. So in this case, since I do not know what is my acceleration, I would work with my equation on the right first. So the sum of forces are actually these two forces. There are only two forces, the 20 Newton and the 15 Newton. So I will just write it down, and since the 15 and the 20 Newton are acting in opposite direction, I need to denote sign notation. So down here I decided that downward will be my positive number. So sum of forces are 20 plus, as you can see I use plus because it's a sum of forces, but in this case the 15 Newton is going up, which is in the opposite direction of my sign notation. So therefore I will write here minus 15, so therefore I will get a net force of 5 Newton. Okay, now since I now know what is my net force, I can substitute into my left equation. I know my F net is 5, I know my mass is 2, I do not know more is my acceleration. So from here I work out that my acceleration is 2.5 meter per second square. So now I know down here acceleration is equals to 2 meter per second square. Now why is it that I want to work out this acceleration? Because the 3 kg block and the 2 kg weight, they are linked by this rope. Meaning that if my 2 kg is accelerating at this speed, my 3 kg block must also be accelerating at the same acceleration. Okay, otherwise the rope will not be in tension. Correct? What do I mean? Imagine the 3 kg block is accelerating faster than the 2 kg weight. What happened? The block here will accelerate faster and therefore having a higher speed. And this guy is falling at a slower speed because of the slower acceleration. Remember, they are released from rest. So if 3 kg block is having a higher acceleration, it will definitely achieve a higher speed and therefore cover a greater distance. So because of that, then your rope here will not be in tension. Okay, because this guy is moving faster. Now, in another case, if this guy is having a greater acceleration than this one, what happens is that the rope will definitely break because this guy is moving faster and having a greater acceleration than this. So in order for the rope to be in tension and also be intact, the acceleration of the 3 kg block and the 2 kg block must be the same. So now we know the acceleration of the 3 kg block. So now we want to analyze what is the forces acting on this 3 kg block. So let's draw a free body diagram. This time I will use red. So on this 3 kg block, I am not really interested in the vertical forces because the vertical forces is the weight and of course the normal contact force, but they are going to balance off each other. Then I also know that there is friction down here as indicated in my question right here. You can see that there is a frictional force and that frictional force is actually what we want to find. And then of course this block is pulled by the rope, so there's a tension force here. Now since the rope from connecting the 3 kg and the 2 kg block are the same rope, they must share the same tension, right? Otherwise the rope will break. If not, it will not be strict as well. So therefore we know that this tension has to be 15 Newton as well. Okay. Now having all this information, we write the two formula again. F net equals to MA and F net equals to sum of forces. And down here you have to denote sign notation. So I'm saying that this direction is your positive direction. Now since we know what is the acceleration, we can work out the F net from our left equation. So we know that your F net is 6. With this, we move on to our right equation. F net is 7. Sum of forces. So there are two forces right here. This guy and this guy. Okay. So sum of forces. My tension is in the positive direction, so it is positive. Sum of forces, so I plus. Now the F, the friction, is in the negative direction, so it's F negative. Now with this, we just need to rearrange our formula and we can get that your friction is 8 Newton. Okay? So the challenge in this MCQ question is that it actually involves many steps. Okay, and you have to isolate the 3 kg block into one free body diagram and the 2 kg block in another free body diagram. And you need to have two insights. Number one is that this acceleration and this acceleration must be the same. And number two, the tension on the 2 kg weight and the 3 kg block is the same. Okay? It is a challenging question, but I hope you understand it now. Whether it is in the syllabus, yes, it is in the syllabus. So you are expected to know how to draw two free body diagrams from one problem context. Okay, now question 12. Question 12 is your VT graph. So the same thing, remember that your gradient represents the acceleration. Okay, so from here, we are seeing A, B, C, D with a lot of words, and you are asked to focus actually on t equals to 60, right? So t equals 60 is right here, meaning that the point that we are interested in is here, and immediately you can make some conclusion. For example, since the y-axis is velocity, it means that at point P, both x and y are sharing the same velocity, meaning the same speed. But, oh, okay. So once you have this realization, you don't really need to analyze A, B, and D, because if you look here, at point P, this velocity factor is the same. But for y, the velocity factor is positive, is positive 20 plus, and in x, it is also positive 20y. Oh, okay. I was too happy. So anyway, C will not be the correct answer because both x and y are sharing the same velocity factor, meaning that they are going in the same direction. And so in C, it is wrong. Do not get confused by the upward trend and the downward trend. The upward trend and the downward trend talks about the gradient. The gradient of x and the gradient of y will have different sign, but the velocity of x and velocity of y, they are still positive, maybe 20 plus. Okay, so C is wrong. If you look at D, they are moving at different speed. Definitely wrong. They are having the same velocity, so they cannot be moving at different speed, meaning that the answer is between A and B. Okay. If you look at B, x is slowing down at the same rate as that of y is speeding up. Okay, x is definitely slowing down, as you can see that the velocity is decreasing, and y is definitely speeding up because the velocity is increasing with time. So the thing that I need to check is whether or not they are going at the same rate. So whether or not they are going at the same rate, I need to check their gradient. Okay, so I'm going to check their gradient. So let's check the gradient of x. Gradient of x is 25, 50 minus 0, 100. I will get a gradient of x. And then after that, I also need to check the gradient of y, which is 40, 100, 0, 0. Okay, did I put everything correctly? Yep, I think I did. Okay, so go and check, and then you can decide whether it's A or B. Okay, I'm not going to do it here.